Hey guys, welcome to Concept and Coding, and this is Shreyansh. So in the interface topic, this is the last topic, functional interface and Lambda expression. This is a Java 8 feature and asked a lot in the interview, right? So this is very important, just a heads up. Okay, so now let's start with this. Let's see what we are going to cover today. What is functional interface? What is Lambda expression? How to use functional interface with Lambda expression? Advantages, type of functional interface, and this is one of the use case, because you know that interface can do a nesting from another not nesting, the functional interface can extend from another interface. So what are the different use cases can come? Okay, so now let's start with what is functional interface. So if an interface contains only one abstract method, then it is known as functional interface. You know that whenever we create an interface, right, and if we don't define anything, by default what it is public and abstract, right? Even if you don't write into an interface, then you know that public and abstract will be added automatically, right? So this is, if you can provide only the signature, this is known as abstract method. This is already we are clear. So if an interface contain only one abstract method, that is known as functional interface. Okay, it is also known as SAM interface. SAM is single abstract method. The same thing, single abstract method. Okay, so @ functional interface keyword can be used, but it is optional. So here if you see that I have created an interface bird and created one abstract method. I haven't written abstract. You know that in interface it will be added public abstract automatically. So this is an abstract method and I have provided only the signature, right? So this is an abstract. So I have used the functional interface keyword, but this is also equivalent to this also. You don't have to use @ functional interface. This is just an optional. So this will also be known as functional interface. Because why? It has only one abstract method. Okay, but what's the difference? Like if you put functional interface and if you try to add another, so now here if you see, I have used the functional interface keyword. Now if you try to add another abstract method, you will get a compilation error. See, okay, so functional interface annotation or keyword restrict you that you cannot add another abstract method. But if you don't use @ functional keyword, if you have only one abstract method, it would be known as functional interface, but it will not force you. If you want to add another, you can add it, get height, then it will not be a functional interface then, because now it has two abstract methods. Okay, so you know, right, why functional interface keyword you can use when you have to restrict that no other abstract method can be added. Okay, just see this also, this example. So I have put an @ functional interface keyword and created one interface bird, and this is my one abstract method. Now see this, what definition says that functional interface contains only one abstract method, means you can have other methods like default. So I can have a default method which has the implementation. So only one abstract method is there. I can have the default method. I can have a static method, and even the object class method. So I have already told you in the class topic that each class, right, is a child of object class. So an object class has certain method like toString, equal, I think hash code. So these are the methods which are present into object class. So these methods are not considered as an abstract. Here if you see that, see this example, normal, not functional interface, just wanted to show a normal. Let's say I have created an interface, test interface, and I have defined a method toString. Right, this is similar to what we have into an object class, right? toString also the same is present, the same, it would be by default public. So public string toString method definition is present here. Now if you create a class which implements this interface, Now you see that you don't have to provide its definition. You don't have to provide its definition. Why? Because you know that each class by default extends from the object class itself. Okay. So generally that's why we say that. So in the interface, if you define any object class methods, you don't have to provide the implementation for it. It's not required. Okay, so this was just a normal interface. Here if you see that I have created a class which is extended this interface, and see, no error. I haven't even implemented this. Why? Because this class by default extends this object class and definition is already provided here. Okay, so in the functional interface you can have only one abstract method, but you can have default method, you can have static method, or you can even have the methods which are present into an object class. Okay, so these are all allowed. So this is still a functional interface because it has only one abstract method, even though it has other methods like default, static, or objects. So in functional interface only one abstract method is allowed, but we can have other methods like default, static, or methods inherited from the object class. Okay, so this is clear. So this is what known as functional interface. Okay, so this is clear, right? What is functional interface? An interface which has only one abstract method, but you can have default, static, and other methods also, but only one abstract should be there. Now the question comes is, hey, then what is Lambda expression and why it always comes whenever we discuss about functional interface? How they are both related to each other? This thing should come to our mind, right? Let me explain you with this. Just don't see this now. Let me first explain this. So what are the different ways to implement the functional interface, or you can say the normal interface, right? So first way, as we already know, using implements keyword. So now let's say I have created a functional interface. It's a very basic interface bird and has one abstract method called canFly. So you know that we can create one class. Let's say for the bird I have created one class eagle. I have implemented this interface using the implement keyword, right? So now it has to provide the definition of this canFly. So it provided the definition of this. So this is one of the way. So now I can create an object of eagle, right? So new eagle. I have created an object of eagle, and the object reference is stored by the bird interface, but this is only just a reference, and you can call this method. This is we have already seen, right? This is very basic. So this is one of the way you can implement the functional interface, like whatever the method you have, use the implement and do it. What is the second way? So this was the first way. What is the second way? Second way is using anonymous class. If you have watched the class topic video, I have explained what is anonymous class, right? A class without a name is called anonymous class. So let's say this is the interface, functional interface. I have interface bird, same, one abstract method, right? And in the main method, without even creating class, implement and all, I can create an anonymous this thing. So bird, an object, right? It will hold the reference of the object which you will create. Now how you will create an anonymous class? So new bird and provide the implementation here, right? So provide the implementation here, override this method canFly and provide this the complete implementation. So new bird, and then the block starts, block end here and semicolon, and within this you have whatever the method you have to provide its definition, right? And so this eagle object which holds the reference of the whatever the new internal, so internally it will create a class, implement it, but it's an anonymous. In the example I showed you that it will create some with a random name which compiler decides, right? The name. So that's why it's known as anonymous class. So internally what it's doing is nothing but the same. it will create one class with its own name and implement this bird, then write a method, this implement this method, and using this eagle object you can access this can fly vertical or not. Okay, so this is, we have already seen that how you can implement the anonymous. This is known as anonymous class, right? So we have already covered that one. So if you are totally not recalling it, so I will suggest that please check what is anonymous class, because there we have explained in depth like internally what it does. It create a new class itself with the name which is decided by the compiler. But this is the way through anonymous. Now what is the third way? So third way is using Lambda expression. So now you know that why Lambda expression is always comes into the picture when we always talk about the functional interface. So it's a way of implementing the interface. Lambda expression is a way to implement the functional interface. One way is using implement, second way is using anonymous, third way is now Lambda in Java 8, right? Now you say that, hey Shreyansh, like why we need Lambda expression to implement when we have already two ways to implement interface. So notice one thing in this two. So let's say this anonymous class. So here you have to implement this method, an interface which has only one abstract method, only one, right? So here if you see there are too much verbose. So only this thing, this line is your, which is you required. Rest is all Java verbose like create a new, this, block start, put override, put a method can fly, and then do this. So here if you see that with the help of Lambda expression, the main intention here is to reduce this verbose, right? So that's why they have used with the functional interface, because in functional interface we know that there would be only one abstract method. So why we need to provide this method name, right? Because we know that functional interface will have only one abstract method. So there is no need to provide the like which method you want to override. It's know that it would be only for the one abstract method. So it tried to reduce the verbose. So now let's see how the Lambda expression can be used. So the same thing, I have a functional interface basic and the can fly one abstract method in the main method. So instead of anonymous, now I am using a Lambda expression. See how? So bird, and this will holds the reference of the object. Okay, now here if you see that this is what Lambda expression is. So this is, you can say that generally the arrow operator or generally the Lambda operator, generally we can say arrow operator or Lambda operator. So first is this. Okay, if your abstract method does not accept any input parameter, then it would be empty. If it accept any input parameter, then you can provide that input parameter. You don't need to give the name and all, that is not even required, because Lambda expression is you have only one method, one abstract method in a functional interface. So no need to use the name, can fly and all. So if your method doesn't accept any input parameter, it would be empty. If it accept, provide it over here. So can fly accept one input parameter, that is string. Well, so I have given one string and it can be one, what is the name of the value. Then this is the arrow operator which says that okay, we are doing a Lambda, implementing the functional interface, right? So this is the Lambda operator, and then you can start the block, finish the block, semicolon at the end, and you can just provide the implementation what we were giving here. Okay, if you have more than one line, right? If you have only one line, then this block also not required. It would simply work like this, system.out.println, right? System.out.println, that's all, finish. If you have more than one line, you have to provide the block. So now you here see that like lot of verbose has been removed out of this using this lambda expression. Okay, so first thing is start this block, provide the arrow operator, and if it is only one line, you don't need these blocks. If you have more than one line, then you need these blocks. You need to provide this block, and inside this provide the implementation. And we can similarly access this like eagle object dot can fly. So you got it. What is the use of lambda expression, right? Why it's always used with functional interface? Okay, so just don't worry about this lambda expression, like it will get more clear with the different examples which I am going to give you. So now let's see the type of functional interface. There are 4 types, right, which is already inbuilt. You can say that this is already inbuilt, right? Sometimes you don't have to write functional interface, you can use it what is already existing. So first type is consumer. So if you see this package java.util.function, inside this package you will see this all 4: consumer, supplier, function and predicate. Okay, so let's see one by one. What is consumer functional interface? So here what it happen is represent an operation that accept a single input parameter and return no result. So its functional interface looks like this. It has @ functional interface, then an interface with name consumer, right, with the name consumer, and it's a generic type. So I think you already know, we have already covered generic classes, right? You already know how this has been handled, right? So this is a generic interface, right? But it's an functional, means only one abstract would be there, one abstract method would be there. So what is the name of the abstract method here? Accept. Okay, so what this consumer says that this functional interface, whatever the abstract method it has, it will accept only one, accept a single input parameter, only single input parameter, and returns no result, Okay, let's see supplier. What supplier says that represent the supplier of the result, accept no input parameter but produces a result. So very similar to this one, I have created a functional interface supplier. It is already there in this package. Okay, again it's a generic one, means you can return anything, string, boolean, integer, whatever you want, right? So here if you see that what this definition says that accept no input parameter. So no input parameter and produces a result. So it produces the result. Okay. Now let's see one by one. I think you got the gist, like what is the types of functional interface, like. So consumer, we already know that this functional interface already exists and which accept one input parameter but returns no output. Okay, and how you can use it? So let's say I have created one main class, main method, right? And I have creating a variable reference where object reference where I will store the object whatever it's gonna create, right? And in this one I want to, let's say, pass integer. So I am passing an integer 1, right? So it accept one parameter, right? So it's a generic, right? So either you can pass integer, string, boolean, whatever you wanted. So I am implementing it with an integer. So it accept one input parameter. So this is not empty. I am passing one integer variable here. Okay, then arrow, that means it's a lambda expression and we are implementing the functional interface. And I have more than one line, so I am using the block start, block end, semicolon. And inside this you can do anything. You don't have to return anything, you just process it. So I am getting a value, so I am just processing it. Hey, value is greater than 10. I am just putting a print, hey, logging, do something. Okay, so some processing. And whatever the objects reference it hold, logging object, you can call this accept method, right? And you pass the value 11. So it will internally invoke this one. It will pass 11 here, 11 greater than 10. It will print logging, right? Very similar to anonymous, but only thing is certain verbose has been reduced. Similarly, when to use supplier? Now if you can use supplier when you don't want to pass any input parameter, but you want to get certain out of it. Okay, so now let's see. Here I am passing, so this is the functional interface. Now I am implementing supplier. This is my object reference, and this is the generic. So I have to tell like what type of whether string, integer or any, I have to give the type. Okay, so here I have given the type. Now here, is it accepting anything? No. So that's why I have created an empty one. And I don't want to create a block. I have only one line. So here if you see that I haven't started or ended the block, I just simply, this is the data I am returning. So it will simply return it. Okay, and this is very equivalent to this what we have seen till now. Supplier, what is the generic type? A string. This is the object reference. No input. So it is just like this. Arrow parameter, a lambda parameter. You can even start the block and the block even for one line also, but now you can like this return. This is the data I am returning, right? So this is the two way. For one line you don't need a block and this don't have to write a return, it will simply return. But when you are creating a block, it would be like a normal, you have to return this like this way, right? And how you can call whatever this object reference you have created, dot get. So this is supplier. No input, but there is a return. Similarly, there is a function. Function says that accept one argument parameter and produces a result. So means it accepts also, it returns also. Okay. So the function interface looks like this. It's a function interface, only one abstract method. And in the generic type, it accepts two types, T and R. So T is your argument, what type it is gonna be, R is your return type. So see how I am implementing function, this one. So it accepts two generic types. So I pass integer. So this would be your integer argument, it will accept. Return type would be of a string. Okay. And the object reference. Now it accepts one parameter. So you have to provide the integer, right? So integer certain data. Okay. Then argument starts, lambda expression starts, provide the implementation, and you can process it like, so whatever the number I am getting, I am just converting it to a string. So num dot to string and return this output. So what I am returning a string. Okay. So you can use this functional interface whenever you accept and return also. So there is one more type of predicate. Predicate is like accept but always return boolean. Accept but always return boolean. Represent function that accepts one argument and returns the boolean. Okay. So I think now can you implement it without even looking, right? It's a very simple, right? So pause it here. Just try to implement this, right? So here it accepts an integer. So it would be like integer, any value, implemented, lambda expression. Let's say if you have more than one line, it block start, block end, semicolon. Now whatever you have processed it, and it should return the boolean, ultimately true, false, whatever it would be. So predicate, whatever the type generic. So let's say whatever the input parameter, let's say I want to pass the integer, is even or not. So I am passing one argument here. Now lambda expression start, my block. I am just checking whether whatever the value I have entered, is it an integer or not. So a basic method, if it's equals to 0, return true, else false. That's all. Okay. And how you can call it is even, whatever the object reference you have created, called dot test method, right? So you know, right, why we are not writing test here. That's what lambda expression resolve internally does. It knows that this functional interface has only one abstract method. We don't have to write test over here. It is very, very similar to anonymous only. Very, very similar to anonymous only. But in anonymous, we have to provide the method name. But lambda expression says that I work only on functional interface. I work only, Lambda expression can only work with functional interface. Functional interface has only one abstract method, so that's where we don't have to provide the method name. Otherwise, it is very, very similar to anonymous implementation. You got this one? So these are the 4 types: consumer, supplier, function, predicate, right? So if you think that apart from this 4, you have certain other requirement, then you can write your own functional interface. But if you think that your requirement gets satisfied with this input or return type, you can use already existing whatever it is available. Okay, if you think that no, I have a total different requirement, I have 4-5 parameters to be entered and need to return or not return, so then you can write your own functional interface. Okay, now let's see. You know that interface can extend each other, so we just need to see that how to handle that use case. So let's say use case 1, functional interface extending non-functional interface. So this is my non-functional interface, basic living thing interface. It has only one abstract method, can breathe. It is extended by a functional interface. Interface bird extends living thing, and it also put one abstract method. So now here if you see that one abstract method here, one abstract method is here. So generally all the parent abstract method is also carry forward, right? So that's why it shows compilation error, because functional interface should have only one abstract method, but because of this extend, any abstract method which is present into the parent interface, that also get added to here. So that's why it's so compilation error. This is wrong, but this is right. So now let's say interface has living thing has default, right? And now I have a functional interface which extends this living thing. This works fine because it has only one abstract method. This is nothing but a default, so it can have a default method. Okay. Second use case, interface extending functional interface. So now I have a functional interface first, living thing, which is a functional interface, means only one abstract method should be there. It has only one abstract method. Now I have an interface bird. It is not a functional interface, it's a normal interface. It extends living thing. It also have one abstract method, but since it extends, this abstract also comes to it, but this is fine, because since we haven't put @functional interface above bird, so we are not restricting that you should have only one abstract method. So you have one and one is coming from your parent extend. So even though you can have two, but now you are not a functional interface, right? So this will work fine because this is, we haven't put the keyword. So it can have more than one abstract method. So this will work fine. Third use case, functional interface extending other functional interface. So see this, I have a functional interface, living thing have one abstract method. I have another functional interface, bird, extending from this, it is also have another abstract method. See, it has can breathe, it has can fly, different method. So means this is one abstract method for this one, and from parent also this is also coming to it. So it has two abstract method, which is wrong. But see this one, if both the functional interface, so this is your parent living thing, this is your child, this extends the living thing. If both have the same method, public boolean can breathe, public by default is public only, public boolean can breathe, both has the same method, right? Then this is allowed. This is just like you overrided it, right? So this is allowed, but different is not allowed, even when the same signature is allowed. And how you can implement it? I think you can do it, right? So now let's say bird interface I have to implement. So you have to create a bird reference object, any object where you will hold it. It is taking empty. So empty, I don't have to pass the parameter. Lambda expression start, can breathe, returns boolean, right? So let's say I don't have to write a block, I just need to return true. So just put true, finish, right? And with this object you can call this method can breathe, object dot can breathe, right? So I have this object is my eagle, lambda this is start, no input parameter, lambda expression start simply returns true, can breathe. So this is clear, right? So this is so generally when the two functional interface one is extended from other, if they both have the same method, then there is no issue because you can easily implement, it will override it. But if it is a different, then it's an issue. So this is pretty much of our functional interface and lambda expression. I think you are just practice it once, and I think you should be now clear like why lambda expression is always comes and used with functional interface. Because one simple answer before we going, lambda expression is a way to implement a functional interface. It is minimizing the verbose which is there in the, let's say, in the previous ways. You don't have to, because functional interface only has one method, abstract method, it don't have to write a method name and all. So that's how it is able to reduce the verbose, right? Okay guys, so just try to implement it once and see is this all getting properly clear to you, and any doubt please feel free to ping me in the comment. Okay guys, see you, bye.